We're practicing factoring, and before I go through examples, I'm just gonna list because there's so many different methods of factoring, right? And these should just ring bells, honestly. So you've got diamond method, you've got factor by grouping, factoring the GCF. What else? Oh, special patterns. So think of like difference of squares. Sum of squares. When I say that, or sorry, like I'm thinking of, sorry, binomial square patterns, which is like a plus parentheses a plus b squared, or parentheses a minus b squared. And so these are like just a few. There are probably more, and I'm just not thinking of them right now. But these are just a few like tools in the toolbox, right? And so there's no one to tell you which one to use when you look at a problem. You just have to have enough practice where you look at it and you're like, oh, like this is what I should start off with, or it looks like this is that. And there's no shortcut. There's just like, oh, there's building familiarity with the problems, and then you see like, oh yeah, like I've done this enough times where I know I look at this problem now and I know how I'm going to approach it. So I just wanted to kind of jog your guys' memory. If you have no clue how to do any of these, then you might want to look at either some of my other videos or just Google them, right? Like diamond method factoring, factor by grouping, factoring the GCF from a polynomial. Like those will definitely turn up other videos as well. But for me, let's just go. I'm just gonna go through these examples fast as I can, so that this video isn't so long, but you can rewatch it as necessary. So for this, first thing I'm gonna do is I notice that they all have an x cubed, x squared, x. I can factor the x, right? So boom, you do that. And once you factor the x, you're left with x squared minus 4x minus 5. So x times x squared, x times this whole thing will give us back this. So don't forget, when I'm factoring, all I'm doing is I'm rewriting it in like smaller chunks, right, into the parts that are multiplying to make this big expression. So after I factor the x, then I have this, and now it's suddenly much easier to deal with. What multiplies to negative 5 and adds up to negative 4? What multiplies to negative 5, so 1, negative 5, negative 1, 5. And which one of these two pairs adds up to negative 4? Well, this one, 1 and negative 5. So I'll go ahead and write x plus 1 times x minus 5. And we're done. That's it. The only thing that made it more complicated was factoring an x right away. But then this part, you've done and looked at before. Okay. Let's look at this one. So 3y to the 5th minus 48y cubed. So again, I want to factor out the GCF, as in I want to factor as much as I can factor out right away, then that's what I want to do. So I'm going to factor 3y cubed from this because I can. I can divide this by 3 and I can divide that by 3. I can divide this by y cubed, I can divide that by y cubed. So I factor the 3y cubed first. After I factor 3y cubed, I'm left with y squared minus 16. This is a difference of squares pattern. So a squared minus b squared is equal to a minus b times a plus b. So in this case, a being y and b being 4. So I've rewritten y squared minus 16 as y minus 4 times y plus 4. Again, if you have no clue how that works, it's definitely in math 2, but you can just Google like, oh, difference of two squares pattern factoring, and you'll see like videos where they do like a ton of examples for that. This video is more for me reminding you that, oh yeah, there's a lot of different methods, and you're gonna have to pull deep into your like bag of tricks to work out these problems. So last, 5z squared plus 30z cubed plus 45z squared. So off top, you can factor 5 from 5, 30 and 45. That should be obvious. And then you could factor also a z squared. So you do that, 5z squared. What are you left with? z squared plus 6z plus 9. Z squared plus 6z plus 9. If I multiply all those by 5z squared, it brings me back here, right? And then what multiplies to 9 and adds up to 6? 3 and 3, because 3 plus 3 makes 6, and 3 times 3 makes 9. Oh, so that's what it's called. Perfect squared trinomial pattern. So z plus 3 times z plus 3 makes this. And the faster way to write that is z plus 3 squared, right? More efficient way. So that's that. Let's look at another problem, or more examples really. That's if I can, so all these I factored a common monomial right away, which I just think about like the GCF when I think about that. Special factoring patterns, sum of two cubes, difference of two cubes. So now in this section, we're introducing a new pattern, cubes, right? So 64x cubed, well, the cube root of that is 4x, and the cube root of 1 is 1. So they've rewritten it to break it down for you to look at and be like, oh, well, you should recognize that 4x to the third power is 64x cubed. And so then we rewrite it as, so really what it's important is identifying A and B, right? So once you do that, you just rewrite it in this format. So in this problem, A is 4x and B is 1. So everywhere there's an A, I'm going to write 4x, and everywhere there's a B, I'm going to write 1. So 4x plus 1, 4x plus 1, 4x to the second power is 16x squared, minus 4x times 1 is just 4x, so minus 4x, and then plus b squared. 1 squared is 1. That's it. If you didn't get that, rewind, watch it again, because I would literally just say the same thing. This is the same, except for a difference of two cubes. Again, the problem is, or the most complicated thing you have to do is identifying A and B, like identifying cubes, right? So when you look at 27x cubed, you should think, okay, well, I know 27 is cube, the cube of 3. And then 8 is also the cube. Cube of what? Cube of 2, right? So now I've identified 3x and 2 as my A and B. So 3x minus 2. 3x to the second power is 9x squared. 3x times 2 is 6x. And 2 squared is 4. So there it is. And then there's just some examples, but I've already talked about them. As in example 2, I literally just talked about these, which are the exact same. Or not the exact same, but same patterns. And so the last one I want to talk about is factoring by grouping. Maybe I'll make another video for example 4, because that's kind of supplemental. But let's look at this. Actually, no, I'll make a second video for example 3 and 4, because we've definitely, or I teach factor by grouping in math 2, and then this using U substitution is a new technique. So yeah, I'll make a new video for 3 and 4. But yeah, that's the gist of it. So let me know if you have any questions, or again, look up additional videos if you need to regarding these, or just rewatch mine, whatever helps.